the syllabus not only talks about historical development, it talks about the effect of engineering innovation on people's lives. Engineering innovation, as you know, is absolutely massive. Bridge design, going from stone, timber, to concrete, to steel, to concrete reinforced steel, and then to alloy steel. Absolutely great improvements. I think the world's longest suspension bridge is 1900 metres now, bridging across to one of the main waterways in Japan. So bridges are able to go incredibly long distances. It's essentially improvements in finite element modelling and mathematical modelling that have allowed all this to happen these days. Historically, it was just straight out trial and error. But see, even elevators, something as simple as an elevator. Before elevators, buildings were only 3-4 stories long because because people needed to climb stairs to get to the top. If you had a 10-storey building, the 10th storey was the cheapest. Because if you had your groceries, you had to walk up 10 stories to get to house by stairs. Once elevators came, then the ground floor became the cheapest, and the higher up you went, the more expensive the apartment became. Simply just because of convenience. And then it became outlook and view was what was important, not the climb to get there. That's essentially the effect of innovation on people's lives. Just before I go, say simple things. Innovation, key points that drive are war and sport. A lot of the engineering innovations that affect us today have come out of high-performance sport, such as Formula One cars, seatbelts for example. Disc brakes is another Formula One and racing invention. Drum brakes were perfectly adequate for road cars, but they would not stop a racing car. They needed to find something that stopped a racing car, and it was disc brakes. War has driven so many inventions. The third industrial revolution was the invention of the transistor and miniaturisation of electronics. Came out of World War II. The World War I, steel was invented or developed in bulk in 1860. They were still experimenting in 1912. Stainless steel came out of an investigation into the best material to make guns with. They physically made a block of steel, went, is it strong, is it rigid, put it out the back. 3 months later it was still there nice and shiny, and they went, oh, look, we've just made stainless steel. Aluminium, World War I Zeppelins. A guy was experimenting, he added 4% copper to aluminium. Did a tensile test, went, no, that didn't do too much, but it's Friday afternoon, I'm going home. He came back Monday and it was 5 times as strong, 4 times as strong. And he went, what's happened here? And he went back, repeated the experiment, week on the day, come back 4 days later and it's strong. He invented a way to strengthen aluminium. Just through sheer dumb luck. If he did the test on a Thursday and not a Friday, they would have never found it out. But that is a World War I German military secret, strengthening of aluminium. That's actually called, just while I think about it, duralumin, which ceased being a commercial alloy in 1929. They have not sold it for almost 100 years. Our textbooks still talk about duralumin. Please don't.